Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, with this episode of Linux Plus, CompTIA Linux Plus, actually. And in this episode, this is going to be version control with Git with Don Pizzette.
Hi, Zach.
that was your.
I know it was my big thing. This is it's going to be a funny show, whether we intend to or not, at least for our UK viewers, because we're going to be learning about Git, and Git is a technology that lets us do managing code, managing changes to code, and versioning, and all of that stuff. So it falls under this umbrella called version control, which is a really important technology if you're in a developer or DevOps environment. Git is a tool you will be using on a regular basis. So in this episode, we're going to see how to get it installed. We'll learn a little bit about how it works, and I'm going to walk you through the process of creating a repository, modifying some code. We're going to check it out, check it back in, and you'll get a chance to see how we're able to follow that history and make sure that we have a good idea of any changes occurring inside of our code base. So that's all coming up right here in this episode.
So you've already hit upon that a little bit, but why is version control so important?
All right. The main reason it's important actually goes beyond the things that I mentioned earlier. In today's world, it is super, super common to have larger development teams and even distributed development teams where the developers, the engineers, they're all over the world, right? So they might not be in the same room as each other. It used to be, back in the old days, the developers all sat in a room together. And if somebody was working on one piece of code, the others, they knew it because they could just look over their shoulder, or they could yell out, hey, is anybody working on this file? And it kind of coordinate that way. But if you have a product that is massive and you have 1,000 people working on it, the odds of two people wanting to work on the same file at the same time is really, really high. And if it's a mission critical product, you don't want somebody writing crappy code, code that's got a bug in it or a security vulnerability, and then they push it into the main code base, and now your product is either not stable or not secure or both, right? Those are things you want to avoid. Git helps us to protect from that, right? Really handy. In fact, the way Git came about, it was created by Linus Torvalds, right? The same guy who created Linux. He created Git as well. And what happened was he released the Linux kernel back in the late 1990s, 1997, right? Well, within 4 or 5 years, there were a lot of people contributing code to the Linux kernel. He's not a one-man shop. It wasn't Linus doing all the work. He had a ton of people volunteering.
And he wanted people to collaborate.
Absolutely, yeah. But he had to have some way to keep it all straight, to make sure that one, he had a chance to review the code so he could make sure that only good code was going in. And two, that it was easy for people to contribute code without stepping on other people's toes. So he created Git to be able to manage Linux kernel development. And it became so popular that over the next 10 years, it became one of the major version control software packages that are out there. There's a number of other ones that are out there. So you might see some people that use CVS or some of the different ones, but Git has become the most popular. And let me just clarify real quick before we get too far into this episode. When I talk about Git, it's just Git, G-I-T. It's one command that we're able to use to manage our source code. There's other products out there like GitHub and GitLab. Those are hosted web-based code vaults. And you're able to use the Git command to send code to them and download code from them. But GitHub and GitLab are not, like, Linus Torvalds is not involved with them. Those are their own little products or projects, and they just support Git as the command to move data in and data out. So you don't need a GitHub account. You don't need GitLab. You don't even need a centralized server to use Git. You can just use it right on your own machine and do version control just for yourself. As you're kind of testing out code and tracking it. You can even use it for non-developer type products. Maybe you just have a bunch of text files that you want to keep track of the changes to, and you can use Git for that. It's really powerful stuff. So that's kind of how we're going to be looking at it through the rest of the episode, is how we work with that command. But it all originated with the Linux kernel. When you have tons of people contributing code, it's too easy for people to butt heads. Or a problem occurs, and now you got to figure out how to roll back that code. How do you get those changes out of there? Well, Git tracks all that and allows us to roll back really easy to be able to keep track of changes and approve them. And it's just a great system for doing that.
So then, how do we get started with Git?
All right. Well, some Linux distros do come with Git prepackaged. A lot of them, it's part of their developer software selection. So when you're installing Linux, if you picked to do a dev environment, they'll usually install Git for you. But if you just choose to do a regular desktop install or a server install, Git is not normally installed. So we're going to need to install it. Ubuntu, Debian, CentOS, Red Hat, Fedora, they've all got Git packages because, again, this is how the Linux kernel development package is maintained. So Git is super popular. Installing it is not any different than any other package. So for example, on mine, I'm going to go ahead and open up a terminal. I'm running CentOS 7. So this is based off of Red Hat Enterprise Linux 7. And if I just fire up a command prompt and type Git, I can see that I don't have the command, right? So it's not installed for me. If I do a sudo yum list git, I can take a look and make sure there's a Git package available, which there should be. It's running nice and slow here. So it's going to reach out and find it. There we go. I've got Git available, version 1.8.3.1. And so if I want to install that, I just need to do a yum install Git. Now, you actually can go to the official Git website and download the source code for Git to compile it if you want a newer version than what's in your repo. But the protocol hasn't changed much. The command hasn't changed much over the last 10 years even. So version number is not something we're normally too terribly concerned about. Once we install it, though, now we'll have that Git command, and we'll be ready to start working with the repository. So let me show you what that looks like. Let's just use as an example. Somebody's already got a project that's published out there, and you just want to get a copy of it. So you want a copy of that project. So for example, I've got a GitHub account, and I have a couple of repositories in there with things that I've worked with. One of them is like a Heartbeat website that I use on AWS resources. So if I want to see if a Linux server that's running in AWS is actually up and operational, I have a simple little web page that shows me all sorts of data about that server. I store it in a GitHub repository. And the reason I do that is I make changes from time to time, and I want to keep track. And I also want to be able to quickly access that data if I'm on a computer somewhere, right? So I can just reach out and do that. So what I'm going to do is I'm going to make a directory called projects. And let me just change into that. So this is going to be the folder where I store the projects that I'm working on. And I'm going to use that git command. And I'm going to say git clone. And then I'm going to specify a location where I can find the project I want to clone. So mine, I mentioned, is stored in GitHub. So I'm going to point to github.com/donpezet/ and this one's just called AWS demo PHP web app.git. All right. So I'm going to point to that address, and it's going to reach out. It's going to talk to the GitHub servers. It's going to find my project and then download all of the source code that's a part of that project. And so now if I take a look at my folder, I've got a new subfolder created called AWS demo PHP web app. And if I go in there, I can see where it's pulled down my index.php file, my readme.markdown file, so it's grabbed this information and brought it down. So now I've got a repository that's sitting right here that I can work with. Now, before I do any actual work with it though, there is a couple of commands we need to run to get Git set up the way, and I should have already done it before. I got lucky here with this command. It didn't require it. But before you can start pushing code changes and so on, Git needs to know who you are, right? Now, Linux knows who you are. You've got a user account. But that doesn't necessarily fly with all the other users on your system. So you have to have a common name that's associated with you that you put as a part of any code changes that you make. So before we use Git, we'll typically run two commands to set up that identity. I'm going to run git config --global user.email, and then I'm going to specify my email address. So I'll just put don@itpro.tv so that it knows my email address. If you want to identify yourself globally, email address is a great way to do it. People know, right? That's me. And then I'm going to do user.name, and in there, in quotes, I can specify my full name. And so now whenever I push a change, it's going to show that that change was for me. People will know. They can look at it. And if they have questions, they can reach out to me and say, Don, was this really you? Or are you sure you want to do this? This is terrible code, or whatever it is, in order to just find out a little more about that. Now, I got lucky when I pulled that git clone earlier. I wasn't changing anything, so it didn't require a name. But if I had changed something, it actually would have failed and told me you've got to define your name. So that should be one of the first things you do to get Git set up. It's harder to say than it should be. So now, we're set up, and I can start to go in and work with the code and make changes, submit them for approval, and I'm all set up. So it's really, you install the Git package, and then you run these 2 commands to set up your email and full name, and now you're all configured.
So what if we are starting from scratch? How do we make our own repo?
Okay, so I pulled from GitHub. So let's kick that out of the picture, right? Because I said you don't actually need GitHub.
Mhm.
I just want to maintain some code right here, and I want to keep track of it. All right. So if you want to do that, first off, you need to create a folder. And so I'm going to make a folder to store this in. So I'm just going to call this Don's project. All right. So this is going to be the Don's project. Very
Excellent.
creative. All right. Now, inside of that project, I need a few files to tell Git that it's going to be monitoring what goes on inside of this folder. If I look in here right now, it's a new folder. So if I do an ls-a, I can see it's empty. Right? There's nothing in there other than the pointers for the actual directory and the parent directory. So no files. If you then run git init, all right, that's going to initialize a repository. It's going to say, I need you to track this folder. You need to create a folder because otherwise you don't want to track like the parent folder. I want to track this folder. So git init. Now, when you run that, it's going to say that it initialized an empty Git repository, right? And it created a file. Now, that file doesn't show up by default because it's hidden. But if you do an ls-a, you'll see it created a .git file, right? And that's actually a folder. So if I go into like cd.git and take a look in here, it's created a bunch of things. Branches, config, description, hooks, info, objects, references. These are all the ways that it's going to be tracking what's changed, what the old versions look like, what the new versions look like, what the branches are. It's tracking all of that right here in this subfolder. That's what makes up the Git repository. When I pulled up my AWS project a minute ago, right here, I showed you guys how it had the index file and the README. I didn't do a long listing to see that .git folder. And if you change into that .git folder, you'll see the same basic thing. And there might be branches or other things that are in here. If you go into objects, you'll start to see all the different objects that are being tracked. Now, I've only got 2 files, but I can see a lot of objects here. Some of these are previous versions of the file. You know, what did it look like before a change occurred? And as you browse around, you'll find some of that stuff stored in different formats. Most of this is readable, not all of it. And that one's not readable. It's a binary file. So some of it you can't read. Some of it you can as you poke around and kind of look at those changes. But it's really not designed to be looked at. You're supposed to ignore that folder because the git command is how we'll interact with a lot of this stuff to go in and change things. For example, if I want to see how many changes were made or if there were pending changes, you could run the git status command, and that'll show you what you've got. Right now, it shows that I'm connected to the branch called master, which is the main copy. I'm connected to the production one, and right now there's nothing to commit. The working directory is clean. Everything is fine. If I go to my new project, I should see the same thing because I haven't done anything yet. Yeah, so when I run it, I can see that there's been an initial commit, which was just when we created it. And then after that, there's nothing to create right now. And it's actually not tracking anything. It's telling me it has nothing to watch. It's just sitting there and it's ready for us to do something.
Well, now that the repo is initialized, do we just copy our files over?
That's a part of it, right? We need to copy our files into it, but then we've actually got to tell Git to track it. It's kind of funny. It doesn't track every file in there, right? If you think about it, when you write a program, you've got source code, and then you compile that into an application. You might only want to track the application, or maybe you want to track the source code, but not the compiled version because you can always recompile, right? So that's not a big deal. So you get to pick and choose what gets monitored. You can tell it to monitor everything if you want, but first I'm going to copy some files over. Like maybe I want that web app that I brought up a moment ago. I want that in my new project, right? So I'm going to copy that. That was in my AWS folder, and it was called index.php. Except here I'm going to rename it, and I'll just call it heartbeat. Or status, we'll call it status.php, right? So that's going to be one part of this project, okay? And then maybe I want a different kind of home page, so a regular HTML page. So I can vim one, we'll do index.html, and I'm going to come in here and just write a quick HTML page. I don't want to do anything too flashy because it gets boring to watch. So we'll just do a header, and I'll say, this is Don's Sites. Woohoo, I've got a website.
Woohoo.
This will be the greatest HTML you guys have ever seen. And then, we could do a paragraph that just says welcome or whatever. And then we can close all this mess out. So right here is just a simple web page, nothing too flashy, right? And with a web page, I'm going to want to come back and edit this in the future, right? As we add news and blogs and pictures and so on. but this is the first version of my website, just
Right.
that little placeholder. Okay. So now I need to tell Git to monitor these files. And I can do it one by one. I can say git add and then specify a name like status.php. That's going to add that file to the tracking list. So it's now going to track every change that happens to that file. Or if I delete it, it's going to track that as well. So it's tracking everything that happens to status.php. It's going to ignore index.html because I haven't told it, right? Now you can do wildcards. So I could say git add star.php and it would monitor all my PHP files. Or you can even just do git add dot. And that says monitor everything. Take everything that's in this folder and add it to the tracked list. So all that's being tracked, and you can run a git status to see what that looks like. Now, when I ran git status a moment ago, it told me there really wasn't anything going on, nothing to commit, and then it's telling me I need to use git add because it has nothing to track. So now when we run git status, it looks a little different, right? I see that I still need an initial commit. I haven't really put anything in, except it now recognizes that there are two new files. Hey, somebody created index.html and somebody created status.php. And so it's tracking those and they're ready to go. And from now on, anytime I modify those files, it's going to know it. But Zach was asking about copying files. If I copy more files in, that git add dot, that just applied to the files that were in there right now. So if I copy another file in, I've got to run git add again and add it. So anytime I add a new file, I've got to make sure I add that to the tracking list. Otherwise, it gets forgotten.
How do we commit changes to the repository, Don?
All right, so I've got some changes. I got some new files. I need these to go in. Now, this is going to be the true initial commit, the first set of data that's going in. And so when we do it, it's actually done the same way if we're making changes and so on. But with this one, I kind of skip the whole approval process. I can just merge this right in and it becomes my code base. So to do that, you say git commit. I'm committing these changes to the repository. And then I'm going to say -m followed by a description. So now I'm going to describe what I did. And so I'm just going to call this my, this will be my first commit of web pages. All right. And the reason I'm sticking a description on here is so that if other people look, they'll know what I did. There's a description. Oh, this is the first copy of the web pages. All right. So he's probably going to come back and make some changes later on. All right. So they have an idea. And I can see there were 2 files changed. And see how it says 26 insertions? They're just 2 files, right? But in those files are 26 lines of text, right? So it's seeing
Makes sense.
26 new lines of data between those 2 files. So it always tracks that. Or it'll show deletions or just modifications if a line changed. In my case, they're all new, so there's not a whole lot to see there. So it's committed those. And if I do a git status now, I can see nothing to commit, working directory is clean because it's all up to date. And if I do a git log, I can see that log of what happened. Here's that first commit of web pages happened, and it was Don Pizzette. There's my email address, right? So it knows because I provided that identity. If I hadn't provided an identity, it would fail. And then the commit itself has this long UID attached to it. And the reason that's there is if something went wrong, I can roll back that commit using that UID, and it'll undo the changes that I made. Now, in this case, it would just delete those files. That's not really effective. But later on, if we make a little change, we might want to roll that change back, and that UID will be really important there. But at this point, my Git data is all up to date. It knows what I did, and it's all kind of put in place.
How do we submit changes to someone else's repository?
All right, so if we want to make a change, what we need to do is you got a couple of choices. You mentioned somebody else's repository.
Somebody else's, yes.
With my own, all I would do is edit the file and then redo what I did just a moment ago, right? That's easy. So if I say, let's say I modify that homepage a little bit. I'm trying to think of a good example here. So let me go back into that index.html. And I was pretty sparse here, right? I just said welcome. So I want to come in and spice that up a little bit and make it say, welcome to my website, right? So
Welcome to my world.
There we go. So there's my change. And so I will save that. And now I've made a change, right?
Yeah.
And if I run git status, I can see I have a modified file. Index.html has been modified. Now, since it's my repository, I can just push that change in, immediately approved, right? So I'm going to go back up to my last commit, and I'm just going to give this one a description of updated homepage, welcome, right? So now it's got a name, and I can run that, and it's going to push it in, and whoops, git commit. Oh, sorry. I did -m. that was my initial commit. I need to do a-a to tell it to go ahead and actually apply that. There we go. And we see one file changed, one insertion, it's showing that that line had data inserted in it, no deletions, and there we go, right? So I just push that in, we're done, right? But if this wasn't my repository, if this was somebody else's, I don't have permission to just go and change somebody's project. What I have to do is make a copy of their project and change my copy, and then I can submit the copy to them to look at, okay? And if they approve it, they can merge it over. They control their repository. This is where the version control comes in. They have control of their own project. Now, what we're doing is I would effectively be pushing a change to them, and they would be pulling the change into their project. And so they call that a pull request or a PR. I'm submitting code to them, and that's a pull request, and they would then pull it into their code. That push-pull kind of model, the terminology gets a little bit weird, but don't worry about it. You don't actually have to know those terms in order to use it. What you do need to understand, though, are branches. Everything I've done so far is on what's called the master branch. If you're modifying the master branch, that's the real production copy of your project. But if you just want to test, or if the project's not yours, you need to create a separate branch. You need to split off into a separate copy, and you modify that copy. All right. So if I want to do that here, I can create one. If you're in a project, you can always check and see what branches exist by running git branch, and that'll show you any branches. So when I run it, I just have one branch called master, right? And that little asterisk right there tells me that's the one that I'm working with by default right now. All right. And if I want to create one, I can use the git branch command followed by a name and actually create one. But when you create a branch, you normally want to do what's called checking it out and say, I'm going to switch from the master over to this new branch. And you can do it as two commands, but it's a little easier if you just combine them. And that's what I normally do is I'll say git checkout -b, and that's telling it I want to create a new branch, and then I'm going to check it out. And then I give it a name. And so maybe this is going to be, I don't know, maybe I'm going to do an HTML5 update or something like that. So I call this the HTML5 update branch. Okay, and I give it a name. See how it says switch to a new branch, HTML5 update. All right. And so if I run git branch, see how the star is on HTML5 update now?
Mm-hmm.
So when I look at this, I still see the same files, right? I see the files in my branch. If the master changes, my files stay the same. I'm not attached to master anymore. And I can go in and I can modify these files. So I go in and I change that index, right? And I'm going to change it. It's not going to be Don's site anymore. Now it's going to be Zach's site.
Yay.
And so we'll update that, right? So there, I made a change. I didn't make a change to the master, though. I just made a change to this branch. There could be 1,000 other devs all connected to master cloning it right now, and they won't see my changes. If they connect to my branch, though, they'll see my changes, all right? And so now that I've made those, I can then submit those to be pulled into the main repository.
Mm-hmm.
So I can send a pull request, which may be as simple as an email. I can email whoever is controlling this repository, and I can say, hey, I've got this branch called HTML5 update, and I've made some changes. I think they make the project better. Take a look at it. And they can then review it. And if they agree, when they look at HTML5 update, they look at that branch. If they agree, then they can pull it in, right? And the way they pull that in is by bringing in my commits. Now, I'm glad I said that because I forgot to commit it. So I need to commit this.
Okay.
So I'm going to do a git commit -a-m and a description. So I'll call this my, I don't know, converted to HTML5, which I didn't actually do, but we'll just pretend, right? So there's my commit. Now, I didn't commit to master. I committed to my branch. So now when they look at the branch, they'll see my changes, okay? And then the owner of the project, if they agree, if they look at it and they like it, they can pull that in. So I need to switch back. I'm going to do git checkout master. So I'm going to switch back to that master branch. And again, you can run git branch to make sure that you actually did switch. I'm now attached to master, right? And now that I'm attached to master, if I take a look at my index file, see how it still says this is Don's site? But you just saw me edit it and change it to Zach.
Mm-hmm.
Well, if I switch back to git checkout HTML5 update, right? And I take a look at that index .html file there. Now it says Zach, right? These files are changing based on which branch I'm attached to. That's
Right.
the really cool part about this. So I'm going to switch back over to master. And the person who owns the master branch is then able to say, hey, I really like that. So I'm going to do git merge, and then they can specify the name of the branch. My branch was HTML5 update, and it's going to merge those changes in to the master branch and combine them. So now they've been brought in. So when I do git branch, I'm still attached to master, but now when I look at that index.html file, I see that exact site. Those changes have been brought in. So that's how we handle that when we're sharing things between users or you're submitting changes. It's kind of done through a request system. The person who controls the master branch is the person who makes the decision over whether that code is allowed in or not.
Thank you, Don. Version control with Git. Amazing episode. I learned an awful lot. I'm sure you did as well. But I think you have something else you'd like to say, huh?
Absolutely. A lot of people think of Git as just the domain of developers. Just developers need to learn it. But I'll tell you, even as a system administrator, I find that I use it quite a bit. If you're writing bash scripts, if you're keeping track of cron jobs and things like that, you can use Git to maintain versions of those files. And there are many times where I find myself saying, what did I change in this? Where did I break it? What did this look like a month ago? That kind of stuff. If you're using Git to track that stuff, it's really, really handy. Be careful if you're using a public code hosting website like GitHub or GitLab, because you can accidentally disclose information on a public site. Most GitHub repositories are public by default. So if you have credentials in a script or something like that, and it gets posted on GitHub, anybody can see those credentials. When you're dealing with private repositories like what I'm doing right here, that's the safest because they stay on your machine, they stay on your network, and you have better control over it. But always be careful with putting credentials inside of Git. They can get cached and they don't go away, right? If you delete the file, they're still cached. You'd have to flush the cache on that repository. So something you want to always avoid.
Very well said, sir. Thank you so very much for your time and your effort. And CompTIA Linux Plus is an amazing series of episodes. Make sure you watch them, analyze them, take notes, and work because that exam is inevitable. It's coming. And don't forget about the supplementary information in the course library. It's there to do one thing, help you be even more successful. So check that out as well. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
And we will see you again soon.
Thank you for watching IT Pro TV.